Hello everyone, can you hear me? Welcome to ITS 450. All right, so today we are going to, as you know, is a lab, and we are going to continue with our topic of cross-site scripting. Okay, so we're going to look at the other problems that we didn't look at before, and then, you know, if you have any questions, let me know. A few reminders, please. Most important at this time is your term project. Make sure that you're making good progress with the term project. Next week, we're going to cover a new topic, probably one of the last labs of the semester, which is the cross-site request forgery lab. So that certainly will be most likely the last lab that you will have to submit. And then after that, you can really just focus on the term project and finishing that up. However, you know, as you know, you should be working on it at this time. All right, before we get started with the lab today, are there any questions?
Nope.
All right, so you can see I'm navigating to, you should be seeing me navigating to the web security labs. And then, as you know, we're looking at the latest of this will be next week's lab, cross-site request forgery. So today we're looking at cross-site scripting. All right, and I'm going to click on PDF here. Right, so this will be, so if you remember, I've already given the lecture for cross-site scripting and described basically the topic. So that should be described by now. Also, you know that this is covered in chapter 11 of your book, right? So you can follow along with the reading. So today I'm really just going to make sure, it's given that we're moving to the next topic, right? We're just going to cover some of the basic ideas, and then you should be able to implement this very easily. Okay, so we talked about cross-site scripting. Would anyone like to describe what cross-site scripting is? What is cross-site scripting?
It's when you when a attacker injects like code that can steal info or something.
Yeah, what type of code?
Java?
JavaScript, not Java, JavaScript.
JavaScript.
Yeah, it's a web type of an attack, web security, JavaScript. And not just steal data, but it can also impersonate who you are, right? So they can pretend to be you. So that's an important distinction. That's where the self-propagating worm comes in, because it's not necessarily stealing information, it's just friending you, right? So it's like, it's adding friends and so on, okay? So hopefully we went over all of this last week. We went over it, and you were responsible for doing this problem last week, and also this one where you stole the cookie, and then the last one where you would send the data to a specific server on a port number, right? And as you know, you were using Netcat to create a listening port for you to receive the data, right? So those are the three problems that you're responsible for completing for today. Right, remember that this lab is going to be due 1 week from today. I believe I've created the Dropbox already, I think. And so you can submit there. So now today we're going to look at the next 4 problems. Okay, we're going to look at the next 4 problems here. And basically, the great thing about these is that the code is provided for you. Okay. So we're going to look at the first one, becoming a victim's friend. So in this and the next task, we will perform an attack similar to what Sammy did to MySpace in 2005. Right, so we've talked about this. So Sammy, i.e. the Sammy worm. We will write an XSS worm that adds Sammy as a friend to any other user that visits Sammy's page. This worm does not self-propagate. That's the task. That's what's going to be accomplished in task number 6, where we will make it self-propagate. In this task, we need to write a malicious JavaScript program that forgets HTTP, that forges HTTP requests. Remember that that's what you need live HTTP headers for, right? So that you can view whenever. So what you need to do is you clear live HTTP headers, then you go to the button that does the thing that you want to mimic. You click on that button, and at that point, that information, that request, that HTTP request will appear on live HTTP headers, and then you can copy that in to the code below, okay? So that forges HTTP requests directly from the victim's browser without the intervention of the attacker. Okay? The objective of the attack is to add Sammy as a friend to the victim. So basically then what does that tell you? The thing that you should be looking at is whenever a valid person wants to add a friend, what do? Well, they go to that page and click on the button add a friend, right? So that's really what you need to do as the attacker and capture that information in live HTTP headers. Okay? So the objective of the attack is to add Sammy as a friend to the victim. We have already created a user called Sammy, and that's in the website that you're using. To add a friend for the victim, we should first find out how a legitimate user, okay, so to add a friend for the victim, we should first find out how a legitimate user finds a friend in ELK, right? More specifically, we need to figure out what is sent to the server when a user adds a friend. And this is where Firefox's HTTP inspection tool can help us get that information. It can display the contents of any HTTP request message sent from the browser. Okay, and that's what I just said. From the contents, we can identify all the parameters in the request section. In section 4, we'll provide more guidelines on how to do this. Once we understand what the add friend HTTP request looks like, we can write a JavaScript program to send out the HTTP request. And here you have the skeleton of the JavaScript code, okay? So basically, you don't have to change most of this. What's important is, you're gonna put something within the script tag. So you have this script, open script, close script, right? Then in this case, we are going to create an object. If you look over here, in this, we're going to use the document object model that allows us to call the window. And we're going to say whenever the window loads, I'm going to associate it with an anonymous function, which is this one. Okay? And then we're just going to create an object within it, right? So what do we do in that function? We create a variable. Notice the name Ajax there. It could be any name that you want. And then you initialize it to null. Then there's a couple of security tokens that websites need to have so that to prevent, let's say that someone was trying to, from another website, was pretending to be you. Well, they would not be able to do so without these tokens. And remember that these tokens can only be grabbed by whomever has same origin. All right, so only that particular website. However, in an injection, this will work because you're injecting the code, and so it will have access to these ELK security tokens, okay, they're just variables that are there. So what you do then basically is you start piecing a whole bunch of variables. If you notice, we have a variable called TS, then we have another variable called token, and notice that they're being pieced together like URLs because you can see the ampersand there, so and then some variable name, and then the actual value, and then another and, the variable name, and then the actual value, and so on. So this is a URL type of encoding, right? Then it says here, construct the HTTP request to add Sammy as a friend. So this is what you have to fill in, which will come from live HTTP headers, right? Is basically when you press the button, that's the information that you need to try out and look for that goes in here. After that, you create and send the object, the request object, right? And you can see here, could be any name. Call it Ajax, let's say, whatever. So it's, you know, you just say new XML HTTP request, right? So you create a new instance of this object, which is important. And then after that is pretty straightforward. You're going to use a GET request. Notice that you will use this send URL, right? That's send URL. And then you specify a few things like the request header and you send. Now, when you look at the live HTTP headers, you need to look for this, for the TS and the token and the URL to see how they all fit in together. Okay, that's really important, guys. Okay, you have to kind of, you know, that part is not totally done for you, so just kind of take a look at, and live HTTP headers will give you the clues as to how to craft this finalized URL. Okay? Any questions so far? No questions?
No, for now.
All right, good. Well, that's good. Let's see. The above code should be placed in the About Me, so it's telling you where to inject it, basically, in the About Me field of Sammy's profile page. This field provides two editing modes, editor mode, which is default, and text mode. The editor mode adds extra HTML code to the text typed into the field, while the text mode does not. Since we do not want any extra code added to your attacking code, the text mode should be enabled before entering the above JavaScript code, which should make sense, right? You're going to add it to the text version. So this can be done by clicking edit on edit HTML, which can be found at the top right of the About Me text field. And then after that, the questions, please answer the following. Explain the purpose of lines 1 and 2. Why are they needed? So I've kind of given you a hint about that. And then the second one is, if the ELF mode application only provides the editor mode for the About Me field, you cannot switch to the text mode. So can you still launch a successful attack? Okay, so you'll have to answer that one as well. All right, and that's problem 3.5. Okay. All right, so now let's see if there's anything else that I should give you here. Right, so in live HTTP headers, when you look at that URL, what you're looking for is, you know, it's going to be like http://xsslab.l.com and then action, friends, add friend, and then you're going to see that you actually need to piece together a string, okay? So I leave that to you guys, but, you know, it should be pretty easy, I think, and then you just replace. You just have to replace that send URL. So really, it could be as simple as grabbing that URL plus TS plus token, right? So you're going to piece together the string. Okay, guys?
Okay.
And that should be it. I mean, it's not really that difficult. Now, one thing I will remind you of is that JavaScript is not very forgiving when you have little typos, okay? So when you have a little typo in JavaScript, it's going to be, you know, you won't know what the error is. So be very careful when you're typing things in JavaScript that, you know, that you type the correct code. All right, so that's basically the explanation for 3.5. So I think with that, you should be able to solve it. And then now we can, so do these sequentially for sure. So then once you complete 3.5, you can start working on 3.6, which is now modifying the victim's profile. All right, so let's take a look at this one. All right, so the objective of this task is to modify the victim's profile when the victim visits Sammy's page. Okay, so you're Bob or Alice, you visit Sammy's page, and then something will happen. So in this case, we will write an XSS worm to complete the task, right? So this is where the worm comes in. This worm does not self-propagate. Okay, so basically it means like you're Bob and you go to Sammy, and then Sammy has this JavaScript code, but the moment you visit Sammy, now that JavaScript code is in your own profile. That's really what we're trying to achieve here. It's, kind of fun. So it's not self-propagating. Similar to the previous task, we need to write a malicious JavaScript program that forges HTTP requests directly from the victim's browser without the intervention of the attacker. To modify profile, we should first, so now instead of adding a friend, keep in mind now you're modifying someone's profile. To modify the profile, we should first find out how a legitimate user edits or modifies his or her profile in Elk. So you'll have to do that same thing, right? How do you do that? So probably, you open the profile text box, and then you clear live HTTP headers, and then you've written something in there, right? And then you press the button. And when you press that button, you capture what's in live HTTP headers again, and that's the information you need. This will obviously have more info. So, so to modify a profile, we should first find out how a legitimate user edits or modifies his or her profile in Elk. More specifically, we need to figure out how the HTTP post request is constructed to modify a user's profile. Again, we will use HTTP inspection tool. And once we understand how the modified profile HTTP post request looks like, we can write a JavaScript program to send out the same HTTP request, okay? And here, once again, you have some JavaScript code that aids in completing the task. So here we can see the basic idea is, again, you have your script. You can see that open script. Over here, you have a closed script, right? And then you're going to do, on window unload, you create an anonymous function. And then here, you will have to figure out the JavaScript code to access the username, user GUID, the timestamp, and security tokens. Then also you will need a username, which here you can see is that's the name of the variable, GUID, that's the name of the variable, security token, just like the previous two. So basically you have these 4 variables, and you can use it to piece together the string that you need. All right, so here you have then the URL var content. This is what you get from live HTTP headers. Then you can create a, figure out what the Sammy GUID, the user account is, figure that out. And then basically you only do this when you're not Sammy. So there it's saying if elk session user GUID not equal to Sammy GUID, then you don't do it. You see that? You can hard code that Sammy GUID if you'd like to make things easier, that's okay. Although you could get everything automatically. And then you just do the same thing you did before. You create an object, you make it into an XML HTTP request. This is going to be a post request now instead of a get HTTP request. Here's send URL. Obviously, this is where send URL is really where the trick is, right? In figuring out send URL, it's going to be made up of whatever content is and all these variables together. So you got to, that's where what you have to piece together. Okay. And then you're going to create the request header, which is, for the site, and then you send the content. Okay. Similar to task number 4, the above code should be placed in the About Me field of Sammy's profile. And the text mode should be enabled before entering the above JavaScript code. And then you'll have to answer the following questions. Why do we need line 1? Well, I already explained why that is, because you don't want to do this for Sammy. And what happens if you remove this line and repeat your attack? So that, go ahead and try that out. Okay. And then you will report and explain your observation. Okay. Are there any questions about this, this problem? Guys, does it make sense?
Yes, Professor.
All right. Wow, great. That's really great. So the variable where you put in your information, you got to figure that out. It's probably the description variable, which you don't see there, but you'll have to figure that one out. And really what you're going to do is you're just going to copy in there, some text, right? So you're going to say, I think the problem in the past, it used to say that you should write in there, Sammy is my hero. So you can do that if you'd like. Okay. But that should be the same idea. So it's very similar, except that the URL, it'll have both URL and content here. All right, so whereas before, like I want to stress something here. Whereas before, if you pay attention, if you look in the previous problem, we had the URL here that you get from live HTTP headers plus combining it with all these variables, and then you would send nothing. You see that? Because everything was in the get. However, in this one, it's a little bit different if you look, because you still have a URL, but you also have content. So you still need to figure out what send URL is, but within the send, guess what? Now you have a content variable. So pay attention to that difference because it's really important. And that comes from the fact that the previous one was a GET request, whereas this one is a POST request. All right, so you start crafting your content here, but you also need to craft your send URL. Okay, which will, that you get from live HTTP headers. The content will probably be something like token plus TS plus name, description, GUID. So you got to figure that out. That's something that you figure out with live HTTP headers. All right. And that's it as well. So that one should be pretty simple and straightforward. Okay. As you can see, these just build on the previous one. These just build on the previous one. All right, so I don't hear any questions. So then we can move on to the final problem that I'm going to ask you to work on, which is the self-propagating XSS worm. So what do you think you would need? In the previous one, we were able to modify the profile and write something like Sammy is my hero, right? So obviously you can make copies, or basically we can write something. But a self-propagating worm means what? What do you think a self-propagating worm means? In this context, how would that work, do you think? Anyone?
it can get another users to have this worm in the profile.
Exactly. So you're saying that if you go to Sammy and Sammy has that JavaScript code, if Alice visits Sammy and Sammy has that JavaScript code, now when she visits, now she will also have that same code, right? She will also have that same JavaScript code on her site. And then that means that if Zelda visits Alice and visits Alice's profile, then now she will have a copy of that JavaScript code and so on, right? That's what a self-propagating worm means, okay? And so how do you guys think you could do that? So the key is that now you need to have a copy of the code every time. So let's think about that a little bit. So let's see the problem here. And you will probably remember this from your you will remember this from your, your 110 when you took JavaScript, etc., and the document object model. All right, so let's read through this problem, 3.7. So to become a real worm, the malicious JavaScript program should be able to propagate itself. Namely, whenever some people view an infected profile, not only will their profiles be modified, but also the worm will also be propagated to their profiles, further affecting others who view the newly infected profiles. This way, the more people view the infected profiles, the faster the worm can propagate. This is exactly the same mechanism used by the Sammy worm. Within just 20 hours of its October 2005 release, over 1 million users were affected, making Sammy one of the fastest spreading viruses of all time. The JavaScript code that can achieve this is called a self-propagating cross-site scripting worm. In this task, you need to implement such a worm which not only modifies the victim's profile and adds the user's Sammy as a friend, but also adds a copy of the worm itself to the victim's profile. Okay? And this way, the victim is turned into an attacker. To achieve self-propagation, when the malicious JavaScript modifies the victim's profile, it should copy itself to the victim's profile. And as it turns out, JavaScript has a very easy mechanism for doing that. There are several approaches to achieve this. Okay, there are several approaches to achieve this. Okay, and we will discuss, two common ones. All right, so the link approach, we just need to do one really. The link approach, if the worm is included using the source attribute in the script tag, okay, writing self-propagating worms is much easier. I agree, that's the easiest one. But it's not necessarily like the most fun or the most like, oh, like novel. Wow, you can do it like this, So this one, it's a little bit kind of boring because it's pretty straightforward. This has been discussed already in task 1, all right? So the source of JavaScript has already been discussed there. And an example is given below. The worm can simply copy the following script tag to the victim's profile, essentially infecting the profile with the same worm. So you can see that there all is happening is you inject this every time, and then you know, that has to be sent. So it's really like whereas in the previous problems, what I want to show you, in the previous problem, you were sending content, right? And the content was just some text like, hello, this is Sammy. In this one, instead of just sending text and hello, this is Sammy, you actually send this. And then by sending this, you actually end up calling this one over here. So you end up calling that, okay? So that's pretty important. Any questions so far? Okay, so that's the link approach. Super straightforward. The second one is the DOM, document object model approach. This one, I always like this one more just because it's, you know, harder, I guess, but just more interesting. If the entire JavaScript program, i.e. the worm, is embedded in the injected profile, to propagate the worm to another profile, the worm code can use the DOM APIs to retrieve a copy of itself from the web page. And an example of this DOM API is given below. And it shows how to do it. And basically the key is the following. You have to use two things. Now the script will have an ID. You guys have done a lot of HTML. You should know that any tag can have an ID, right? So you create the tag script ID. So it's just like, you know, here, right? You would put, or go back up here, right? These scripts didn't have an ID, but you can give it an ID. And then once you have an ID for a tag, then just like you learned with jQuery and everything else in regular JavaScript, you can always quite simply just use the document get element by ID. Which ID? Worm. So in essence, it gets itself, right? So if you can see, this is a self-propagating worm because, you know, you're going to put together some string here, right? A JavaScript string, notice. And you need to escape certain characters. You can see that there. But basically you're saying script ID worm, right? That's, you give that name, and then you do document.get element by ID worm. So what happens is that it gets itself, okay? But it gets itself without the script tag. So it actually literally only gets this part, right? Because it says inner HTML. So it's gonna skip the outer script tags. And that's why in here, in this line, you can see that that's being added. Okay, you can see the opening script tag and the closing script tag called the header tag and the tail tag, basically. Okay, and that's it. With that, now you can build a worm code by doing header tag plus JS code plus tail tag, and then encode URI component. And then after that, once you do this code is just to illustrate, you know, to view it. You know, you pop up an alert. Okay, guys. However, this code has no payload of any kind, right? So that's the thing. But this shows you the basic idea of how to get it through the document object model. Did this make sense, guys? Any questions so far?
No questions.
All clear? All right, good.
Yep.
All right, good. Okay, so that's, you know, these are nice because they're very sequential, you know, so they're very sequential in the way that they're done. It should be noted that inner HTML only gives us the inside part, which I just said of the code, not including the surrounding script tags. So we just need to add the beginning script tag, this one, and the ending script tags, right? And to form an identical copy of the malicious code. When the data are sent in HTTP post request with the content type set to which is the type used in our code, the data should be encoded. The encoding scheme is called URL encoding, as you know, which replaces non-alphanumeric characters in the data with the percentage something characters called a percentage sign, or and so on. And the encode URI component function can be used to URL encode. So as you can see, we're just going to follow the guidance of the book. Try, or the PDF. Try both, but the one that's really required is the DOME approach. Okay, because it's the more challenging, the most fun. So really, this one is going to be the one that I'll be looking for in your lab report. Okay, and that's it. That is the lab, really. Obviously, you're going to have to copy some elements of this one, right? Because you're still going to need, you might want to do, modify the profile. So you need to kind of combine both of these, but it should be pretty clear how to do it. And then after that, so that's it as far as the problems. You can read through 3.8 and 3.9. 3.9. I'm not going to ask you to submit these, but I will ask you to read them, because you will need to read them for your exam and for your term project. Okay, so make sure you do these, but basically we can go over it. So ELK's countermeasures. This subsection is only for information, and there is no specific task to do. It shows how ELK defends against the XSS attack. Okay, ELK does have built-in countermeasures, and we have they have been deactivated and commented out to make the attack work. So there are two countermeasures. One is a custom-built security plugin, HTML odd, which on activation validates the user input and removes the tags from the input. As you can see, once again, all of these attacks are solved with input validation. Okay. This specific plugin is registered to the function filter tags in the ELK engine lib input PHP file, and you should read through that one. To turn on the countermeasure, log into the application as admin, go to account administration, top right of the screen, plugins, and you can follow the instructions from there. Another security mechanism is called HTML special characters, which is used to encode the special characters in user input, such as the less than symbol. So notice this is similar to the SQL injection mechanisms, right? And it's going to encode it to this, and this one will be encoded to that. So you can go to that file and look for that function in that specific file, and you'll see how it works. Okay, which is used for those particular text.php, URL PHP, dropdown PHP, email PHP files, and so on. So those are the two countermeasures. So now you know, and you'll be able to answer those questions in your project and on the exam. All right. And then this is the content security policy mechanism. You can read through that one as well. I'll leave that. It's not a requirement, but I'll leave that to you guys to read. I don't have to read everything for you. All right. This is the code to create the server for listening on a port. You can see it's written in Python. Notice it's written Python 3. So just be aware of that. But, it should be you guys are Python experts by now. All right. Okay, and that's pretty much it for the lab, or the lab instructions. So let me see. Let me just double check on the self-propagating worm, which is the last problem of this lab. Just want to make sure that I've given you all the details. So remember, the same thing happens. The hard part here might be that you have to, you have to take the URL, you have to take the content, and the content is a combination of tokens plus the TS variable plus name plus the description, GUID, where the description is really the one that will contain now the self-propagating worm, okay? But it's pretty much the same code. Sometimes you can use the concatenation function in JavaScript instead of the plus, all right? So just explore that. You can concatenate things at the end of a string. So these are the problems for this lab, okay? There's nothing, that's it as far as this lab. So this lab will be due 1 week from today, okay? Have I created the Dropbox for this lab, guys? Do you know? Anyone know? So let me go ahead and check for that.
Yeah, it's already created.
Already there? Oh, okay.
Yeah.
When is it due?
On the 19th.
Huh?
19th? 19th?
All right, I'm going there right now. All right, so let's see. I'm going to share. You should be seeing my bright space now, and if we go to cross-site scripting, oh yeah, that's already there. It's due November 19th. Okay, so November 19th is okay, so software assurance, so November 19th, that's, okay, yeah. So a week from today, so I said next week, I'm gonna here on the 17th, I'm gonna do the lecture for the cross-site request forgery. Then we've got Thanksgiving, so just some miscellaneous topics and wrap up. And then finally the last week where you can work on the project. So as you can see, guys, your presentations are December 8th. You literally have 1, 2, 3.5 weeks, right? 3.5 weeks. Did we say that we were doing demos today of the project?
I thought we were doing it next week.
Make sure, please, that you're working on this, okay? Next week, okay, that's what we said, all right. Thank you. I thought we had said this week, but I guess I'm all right. So the reason why I do this, and I'll provide a grade again, but it's just I want to make sure everyone's on track, right? Even I get nervous with these projects when I want to see where you guys are with them. You haven't asked many questions about them this semester, so I assume it's because of the online, but still, ask. All right. Hopefully this should make sense, right? Do you guys understand cross-site scripting? Is there anything about it that you don't get?
I understand it.
All right, and I without giving you the code, I've pretty much giving the PDF is actually written really well. So other than telling you how to add all the components together to create the the JS code or to create the content, that's really all you have to do. Because this structure you use very well. Remember, you're going to use this one, right, in the next problem. So the code from task 5 you use in task 6, except that you just have to add more of it now. You have to add this as well. Okay. All right. So today is lab, so you know I don't have anything else to do except to help you out. So I'll stay here for the whole lab session and let you work on your lab. And if you have any questions, please ask. Okay. Since I'm not going to give you any new content at this time, I'm just going to pause the video. Okay.